All right. Good morning.
Good morning.
Good morning. Okay. You guys are super enthused this morning. Okay. All right. So we have like 3 lessons for this, and we're gonna finish it in 3 lessons. That means Thursday and Friday are gonna be days to work on your assignments. All late work that you owe to me that would like to get any points at all has to be to me by Wednesday. Okay. After Wednesday, I can't take anything. Okay, because that's like, I'm seriously behind on grading. Students are actually turning stuff in because it's the end of the 9 weeks. And so I have like an 18-inch stack of homework to grade. So there's my next 2 weeks worth of stuff. Anyway, all right, so remind you again, Monday, Tuesday next week. This is for those people that aren't in class. All right, so let's go ahead. All right, so separation, first order differential equation, slope field, and Euler's method. All right, so I'm going to start off with the separation first order differential. Now, here's super basic, like the most basic thing I could try and explain it as. All variables, all x's on the left, all y's on the right. That's it. There's an equal sign in between. That's the most basic I could give you. So x is on, crap, I said it backwards. X is on the right, y is on the left. Because it usually comes out with a differential equation where it's going to look like this, where it's a dy dx. Dy dx, that means you're going to have your y's on the left and your x's on the right, and we're going to treat it like it is just algebra. Okay, so if we're starting with this right here, I'm going to divide both sides by secant y, because if you notice, I have 2 different problems here. So I have an x and a y. When we did differential equations for my derivatives, I would actually take the derivative and use it like a product or something like that when I add a dy dx or whatever it is, or dy dt, whatever it was in terms of that variable. Okay, now separate. We would divide both sides by secant x, which goes over here. But then, like I said, I'm going to treat it like it is algebra. Multiply both sides by dx. Okay, and that's why dx ends up over here now. So now that I have a dx on the right and a dy on the left, so they are now separated. So now from that point right there, I could actually go ahead and do a, I could do integration of that. I could integrate it on the left side and integrate it on the right side. Okay, find the general solution. Now, the general solution is with the value of c. Okay, particular solution has no c because I found for it. Does that make sense? Particular, no c. General has a c for whatever c value I give you. All right, find the general solution of this. So I'm going to start by, okay, dividing both sides by y squared. So it's going to be dy on the left, right? But it's going to be 1 over y squared. I like writing it like this because it makes it a little bit easier to notice where things are. Equals, and I'm going to multiply both sides by dx, so that's going to give me a 3x dx. And we always said that the dx is just a delta x, right? And to undo that, I would integrate that. So let's integrate that to find out what I'm going to end up with. So if I integrate this on both sides, like this on the left says I'm going to take an integration in terms of y. This over here on the right says I'm going to take an integration in terms of x. So as I do this right here, on the left hand side, I'm going to move that y squared up, which would make it a y to the negative 2, right? Mm-hmm. So y to the negative 2. And remember, when I take an integration, I add 1 to the exponent. Okay, what would I end up with over here on the left? Okay, yeah, so it's going to be, I'm going to have a negative, right? 1 over y. Yes?
Yeah.
Okay, so, and this goes away, doesn't it? So I would normally have a plus c here, right? Say yes.
Yeah. Yes.
I normally have a plus c here, but I am not going to put it here. Because what would happen if I add it here and I add it on the right-hand side also?
We're gonna have 3.
It's going to cancel out, isn't it?
Yeah.
Because I would add it here, but I'd move it to the side, and it would cancel out. But it's basically going to look like this. It's going to be like a plus c1, okay, equals, now over here, you'll see what I'm going to do with that c1 and c2 here in a moment. Over here, so again, I'm going to add 1 to my exponent. Okay. You like fall asleep right there. I'm watching it. It's yeah. So equals. So that's going to be 3x squared over 2. And plus c2. And you're not going to need to do the c1 and c2 here. So if I were to subtract c1, I would end up having it over here, right? So eventually I would have like a c2 minus c1, but we said c is just going to be some constant, right? So, and I have c2 minus c1, which is still going to give me another constant. Some other constant, there isn't a variable, so it's just going to be a c value. You okay, Odin?
Oh,
We all right?
no, I fell on the way here. I got past the
Oh.
Band-Aid.
Yeah, kind of like mid-video, so can you want to sanitize it real quick? You probably should. Yeah, I know. Just don't cry too much, because we are recording this. Okay. All right, so that's what I said. So the c's are just going to eventually become just some c value, okay? Just some value. So it is what it is. So I have negative 1 over y equals 3x squared over 2 plus, you know what? When I combine them together, I'm just going to get some c. Yeah. Are we okay?
So it doesn't matter when you put the C in, it's just gonna be some.
Yeah, it's just going to be some c. That's what I was trying to make it a point here. It's some c1 over here and it's some c2 over here. Then when I move it over, it's going to be some c2 minus some c1, which is still going to give me some c, whatever that is. So I'd still end up with some value for c. So just combine together and just say c. I always put c on the right-hand side anyway. Yes?
So the dy and dx's get taken away?
Yes, because when we do the integration of that, that goes away. Yes. All right, so what do we have here? This would be my general solution. I have a general solution here. It's kind of ugly. Life goes on, though. But I did what I had to do. I solved for it, right? Okay, I took care of it, integrated it, I solved for c. No, I haven't solved for c yet. So there's my c there. So there's my general solution. And now the next thing is going to be my particular solution. Remember when we did differential equations when we had derivatives? A lot of them were ugly, right? They look something like this. Yeah, we had something nasty with blah, blah, blah. So what we're going to do right now is we're going to solve for that c. So what I'm going to do is whenever I see the y value here, I'm going to plug in 2. And when I see the x value, I'm going to plug in 1. So that means that over here, look, I'll even change colors for this one. Look, bam, right here. Actually, no, I don't want that color. I want that color right there. Okay, so I'm plugging in 2 for the y. So negative 1/2 equals, so that's going to be a positive 1 for x. So that's going to be 3 over 2 plus c. I'm going to subtract that from both sides. Subtracting 3/2 from both sides, which is going to give me a -4/2, which gives me -2. So -2 equals C. So my particular solution in this case is going to be that I'm going to have -1 over y equals 3x squared over 2 minus 2. Now, I don't have a problem with ugly equations. What do you think that they might make you do for this problem here, especially if it's a multiple choice?
Standard form.
Yeah. Write in standard form. Can you algebra that one? Okay. Algebra that one real quick. See if you can make it into a y equals for me. Please tell me you're not trying to make it into y equals mx plus b, right? It's not going to work because you have an x squared. Standard form would be everything on the left and equals 0, if that makes better sense. PQ, did you guys get it yet? You distribute your y?
I don't think that
Huh?
we have a y to
Sure. Distribute the y. Multiply it all out. So there's a 2 right here, right? Okay. Multiply everything by y. If I multiply everything by y, -1 equals 3 over 2x squared y minus 2y. Multiply everything by 2. So -2 equals 3x squared y minus 4y. Move everything to the left. It's going to be a -3x squared y plus 4y minus 2 equals 0.
We have to distribute the y.
Isn't that what I said? Distribute y?
Yeah.
Wow.
How do you distribute to the 2 line?
Oh, okay. Yeah.
I mean, like, we have to foil, not foil, but we have to.
Yeah, it's called distribute. Okay. Use a slope field to represent the solution of first order differential equation. Now, a slope field is a graph of a general solution. Okay. I'm actually skipping a slide to show you what a I'm going to come back to the previous slide. You got to see what a slope field is. Now, you notice all it is, a slope field, it's just my general solution plugging in each point with the x and y. So, let's see. I'm going to kind of make up an, actually no, this one's pretty easy. All right, so see this right here, going up and down on the y. So if I plug in 0, 0, what's my slope? 0. If I plug in 0, 1, what's my slope? 0. So I'm just finding the slope for this whole thing. If I plug in 0, 2, my slope is 0. Okay, it's just you're plugging in, so I'm going to pretend like this is 1 over here. Okay, so I'm going to plug in 1, 2, 1, 2, 3. So at 2, 3, my slope looks like it is positive 1. But if I plug in negative 2, 3, my slope is negative 1. That's what slope field is. Okay, all you have to do is just start plugging in your points, and you get what you get. And you don't throw a fit. Okay, so one of the things that actually is super important, if you are looking at a slope field and there is something okay, so I'm trying not to mess up this one. So let's go that's a comma. And you end up with something like this. That means that the x does not matter and the slope is the same all the way across. All the way across. So going left and right, the slope will be exactly the same at whatever it is. So let's say, for instance, it's going to look like this. Bam, 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 bam. Like that. So if it's exactly the same going all the way across, that means the x doesn't matter. So you could tell what type of equation it is. The x is not going to matter. The same thing would be true if you had something going like this. That would mean that the going up and down, the y doesn't matter. Q, are you okay? You keep staring at that thing.
Yeah, it's just
Oh, okay. Okay, use slope field to represent solution for the differential equation dy dx equals y. So what do I need to do? I need to make a general solution first. Okay, so I'm going to make a general solution. So to make a general solution, what do I got to do? Multiply by dx and divide by y. Okay, so it's going to be 1 over y dy is equal to dx, right? So when I take an integration of that, what is the integration of 1 over y? ln y. Equals. Yep. Okay, there's 1 there. But what is it going to be when I take the integration of a 1? No, remember integration we add. Derivative we subtract. Yeah, just x. Plus c. Okay. Now, let's see what that's going to look like. Try not to make it too big, because this actually is very time consuming. There we go. So it's basically, yeah. You okay? All right, good. All right, so I'm going to go through and I'm going to start plugging in some numbers for this. So if I plug in points, what about 0, 0?
ln 0 is 1.
ln 0. ln 0 is 1. And c is, and x is,
0.
okay.
So c equals 1.
Okay. So that would be just a 1 there, right?
It's positive.
Okay, so there's my general solution for that, right? So a general solution says that I would have ln of y, right, equals x plus 1. Okay, so there's a particular solution in that case. Okay, so now I've gone through and found a particular solution for that, but we don't have to actually go through and do all that. We just need to find the slopes, right? And when we're dealing with slopes, what do I have? I already have a dy dx, right? Yeah, I have a dy dx, don't I? So since I have a dy dx, there we go, right? I could just use this. So at my 0, 0, my slope right there is 0. Okay, at 0, 1, x is 0, y is 1. Jennifer, you gonna stand up? I'm worried you're gonna fall out the chair. So at 0, 1, it's gonna be 1, right? Okay. At 0, 2, slope is 2, right? All right. At 0, negative 1. At 0, negative 2. All right, so now let's go to the right. At 1, 0. Zero, right? Because the only thing I'm plugging in is the y value, right? Does that make sense? At 1, 0, the slope is 0. Okay, at 1, 1, positive 1, right? At 1, 2, at 1, negative 1, at 1, negative 2. Now let's back it up over here. Now, negative 1, 0. Negative 1, 0. At negative 1, 1. Negative 1 and 2. Negative 1, negative 1. Negative 1, negative 2. Now if you notice, going left to right, all the way across, right? The x doesn't matter. All the slopes are the same, reading it left to right. So that means the x doesn't play a part into this. So that means it's going to help me out that there is no x in as part of this. Easy or no? Maybe? Yeah.
Wait, so where are you plugging in the points into it? To x and y or into?
Yeah, my x and y in here. If you notice, there is no x, right? Remember, dy dx is the slope. That's the derivative, right? If I took a derivative of some function, I come up with dy dx, right? So, and there's only a y, so that means that that's the only thing I'm plugging in. Okay? So, same rule. If there's no y value, it's going to look like this going up and down. Okay? All right, let's try this one over here. So, is it the same going up and down?
Going up and down,
Yeah, so the y didn't play a part in it, did it?
no.
Y did not play a part, but it's the same going up and down. So it looks like it is, right? Okay. So if I'm looking at all those slopes right there, what does it look like I end up with here?
Probably just a X. Or the positive X, or it's positive slopes, and negative slopes. So it's just an X.
Okay. Yeah, that's good. What about all those slopes together? Just think about it. All the slopes together. If I was given a C value somewhere and I was going to have to connect the dots, think of it as like a flow of water.
Oh, like x squared.
It looks like an x squared, doesn't it? It looks like a parabola, isn't it?
Yeah.
So think of this as like a flow of water. That's the way it's going to end up going. So as it goes there, then it's going to keep going up and over and yeah, right? Looks like an x squared. All right, so let's take a look. I'm going to start plugging in some numbers here. Okay, right here going up and down, those are the easiest ones to look at. The 0, 0, right? So if the slope is 0, which I could tell here, up and down right here, those slopes are 0. So if I plug in 0, I should get 0. So right here, x is, okay, x is 0, y is -1, right? X is 0, y is -1. Okay, so if I were to put that here, okay, would this one work? Would that one give me 0? Plug in 0. Okay, I get 0 and there's no y, right? Okay, so that one will work. What about B? Patar? You're zoning out. Yeah, you say you're thinking, but when your head starts bobbing like to the side, yeah, it's not even an agreement thing. You know, your mouth starts open a little bit. You got a little bit of drool coming out. So, all right, at least pretend a little bit better. All right, so what about B? If I'm plugging in 0, -1 for B, what's that going to give me? -1. So does it look like my slope is -1 at 0, -1? No. So I'm going to cross that one out. So I could actually use this to my advantage. Okay, how about for C? Does that still work? Okay. And what about for D? It'd be a positive one, but that one doesn't work, does it? Okay. So it looks like it's one of these two here. Okay, so if I plug in any of them on my y-axis, it's going to give me the same value of 0, right? Okay, so I know that's going to be helpful there. So I got to pick somewhere else. Okay, I got to pick somewhere else. So I'm going to go over here, which looks like 2, 0. So I don't know what the slope actually is. I just know that the slope is positive. I know it's positive, right? That's super helpful. So if I plug that in, for A, I would get -2. But for C, I get, so therefore my answer is C. All right, and time to play with the calculator. So please grab your calculators.
So 27 and 23, 22.
Okay, so now I had to do an update recently, and I haven't had a chance to do the slope field on this since, but let's go ahead and go to my scratch pad. Okay, yeah. Go push it all the way down on the thing. Is it even charging? As the thing lights up? Any of them lighting up? Okay, so there is power on. Okay. And what was my value? I'm trying to remember this one. 'Cause it's different now. So let's say that my function was dy dx equals x. Alright, let's see. Help me, Google. You're my only hope.
Are we gonna have a video in our video?
Why not? Let's see. All these are the casts where we don't have casts. We have the CX. CAS is not allowed on any of these special tests.
Why? Does it help you too much?
Huh?
Does it help you?
Yeah, it solves everything. So it's banned. Okay, so we're gonna say that y prime equals
Wait, how do you do what from?
it's the accent is the yeah, it's just the apostrophe x. Let me see. doesn't like me. All right, how about this? I'm gonna do this, then I don't have to make a fool of myself on this video. All right.